Bismillahirrahmanirrahim. Assalamu alaikum. My name is Gharbi Akram Abderraouf. I am PhD student at University of Biskra. Our paper title is Tensor Feature Fusion and Multilinear Subspace Learning for Person Identification. Let's start with the outline. We have an introduction in person identification, outline of the proposed approach, and finally the conclusion. Introduction in person identification. Person identification is a challenging task in computer vision that aims to match individuals across different non-overlapping camera views. For example, we can detect discrete images in different gallery images. Several problems are existing with person ID system due to various factors such as low resolution, occlusion, illumination variation, pose changes, and lack of label data. These images shows some challenges. Person ID system contains three principal phases: feature extraction, subspace linear projection, and matching. The extraction features operation is conducted on both the probe and the gallery. Then we get a features vector for each image. After that, subspace linear projection is applied to change the feature representation and achieve a new representation with more separability between different individuals and decreasing the within class. Last phase is matching, where the images are ranked as the similarity. This table shows the dataset that we used in theirs and theirs parameters. Outline of the proposed approach. Our main contributions: a new multilinear tensor representation of features based on CNN, LOMO, and GOG descriptors was proposed. A new multilinear subspace projection algorithm named Khider was proposed. To evaluate our method, we conducted experiments on two challenging person identification datasets, Viper and Pride 450. Tensor feature representation. We merged three feature tensor representation in one tensor to achieve robust features. This merge allows for capturing both spatial and semantic information and improves the discriminative capabilities. Each descriptor generates a feature vector from each image. The feature vector is split into 4 parts, so we have a tensor with 3 modes, and then we create a combination between 2 of the 3 tensors as shown. The proposed approach pipeline. In offline phase, Khider algorithm projects the tensor features on a new discriminant subspace and reduces the dimension of mode 1 and mode 2. Mode 3 remains the same. In online phase, the same Khider rule occur on the probe of per image. Then Mahalanobis distance is computing and matching the probe with the gallery. The experimental results of the two used datasets are shown in Table 1 and Table 2. In general, we noted that the best scores is achieved in dimension 200 and 250 by CNN LOMO descriptor. In curves, in Pride dataset, we note the CNN LOMO is overtaken CNN GOG, but the both are nearly equal from rank 10 to rank 20. In Viper dataset, CNN LOMO is overtaken CNN GOG in all ranks. Table 3 shows the comparison of our method with previous method. We achieve a best result against other method. Finally, the conclusion. In this paper, we propose a novel approach for person identification by combining tensor feature representation based on CNN, LOMO, and GOG descriptors and multilinear subspace learning technique Khider, which is used to reduce the high dimension of the high-order tensor and create a new features representation with augmentation of the interclass and detraction of the intraclass. Thank you for your attention.